Hey, my name is Aditya Pillai. I'm in charge of the software application subsystem, and my major is computer engineering.
My name is Brian Holt. I'm in electrical engineering, and I'm in charge of the sensor interfacing subsystem.
My name is Seth File. I'm in charge of the power system subsystem, and I'm an electrical engineer.
Hi, I'm Adam Popper. I'm an electrical engineer, and I'm in charge of the reporting subsystem.
So we're Team 34, and our team name is Solar Scouts. Our project is the construction of an AgGrow data cart. It's a main tool for farmers and researchers to use for surveying cornfields. This includes counting corn stalks, collecting satellite data, and GPS location. And now this can be done with the cart with less time and energy. Individually, these tasks can take days and introduce many human errors in manually collecting the data, but with this cart, it will allow autonomous data collection with little to no error. The data can be easily understood, as our project also includes an iPhone application which saves all the data through Bluetooth as you collect it in the field and interprets it for you.
All right, so this is the power system subsystem. Right here we have our lithium-ion rechargeable battery. Currently, we are waiting on parts to integrate the charging circuit, but a PDF of the circuit diagram will be included on this video. This right here is the 3.3 volt buck converter. It powers necessary systems like the microcontroller and all the sensors and the sensor interfacing subsystem. This is a 5 volt buck converter. It's taking the 7.4 voltage from the battery and converting it to usable 5 volts for the screen that we have chosen. And as you can see, the screen is currently on and powered. So that is the system.
For this portion of the demonstration, we will be demonstrating the requirements related to the sensor interfacing subsystem. These are requirements 5 through 9. So that includes collecting ambient sunlight data, ambient temperature data, relative humidity data, a count of the corn stalks, which will be accomplished through a LiDAR distance sensor, and GPS location data. So here, this is a 2-in-1 sensor which collects the temperature and relative humidity. This sensor collects ambient lux, which is visible light intensity. This sensor connects to GPS satellites and collects latitude and longitude data, and this sensor collects data related to how far away an object is in millimeters from the sensor. So if we look at the output over here, I'm connected to the ESP32 through serial communication, and I'm setting it up to ping all of these sensors on a 5-second interval. So it's collecting data which is being continuously updated. You can see the latitude and longitude data here, the relative humidity, ambient temperature, and distance from the LiDAR. And then we can do a little experiment here. I will show the data values update as the inputs are changed. So I'm going to hold my hand close to the distance sensor, and the distance away from the sensor becomes very small, and then I take my hand away, and now it becomes very large. And then you can also see with the temperature, if I hold my hand close to the temperature sensor, the temperature increases from the heat from my hand. And then you could also see that the lux reduced to a very small value, because I was also covering the lux sensor, which created a shadow, reducing the amount of visible light.
This is the mid-semester design demonstration of the reporting subsystem. This subsystem composes of our microcontroller, which will control the automated data collection as well as transmission over Bluetooth through the use of a Gantt server hosted on this device, which an application will then read and collect data. That will be demonstrated in the software demonstration later in this video. The next thing is our LCD screen. Our LCD screen will display current data and allow the user to know if the data is actually being read. Finally, to demonstrate sensor interfacing, we have introduced a LiDAR sensor to this demonstration to show that the sensor interfacing has begun to happen with our microcontroller and our reporting code. The purpose of this demonstration will be to show requirement 4, which is automated data collection and storage is facilitated through the microcontroller. Now let us begin by powering our microcontroller. We see that once we have power to the microcontroller, that the first thing it does is establishes a Gantt server. This allows connection from our microcontroller to an external device. We will see this demonstration later in this video as the software reporting system. Once it is done establishing its Gantt server, it then begins the sensor interfacing protocol, which for the cases of this demonstration and simplicity, we introduced the LiDAR sensor. The LiDAR sensor provides real-time data, as we can see that as we move our hands, the sensitivity is not only great, but it updates rather quickly. This is important for this sensor, which is why we wanted to demonstrate this sensor as one of the highest polling sensors and most important to our system. Finally, we want to take a look at the LCD screen. This displays current data as well as provides user comfortable use of this application, knowing that their data is actually being collected and allows them to provide some form of input validation as they're collecting data. This has been the reporting subsystem for AgGrow Data Cart.
So the Bluetooth Low Energy protocol is what allows my subsystem to communicate with Adam's subsystem, being the microcontroller, and my subsystem being the iPhone application. To start, to establish connection between the two devices is using GAP protocol, and in this scenario, the iPhone is the central and the microcontroller is the peripheral. This is what allows me to detect a device and connect to it directly. However, to transmit data is using a GATT protocol, and GATT is how data is transmitted. Here, the microcontroller being Adam's subsystem is the GATT server, and the iPhone is the GATT client. So essentially, as the client being the iPhone, I'm reading data from him being the server, and that's how I'm able to read the attributes of the user ID. So right now we're going to demonstrate our connection between the Bluetooth module as well as the iPhone app. Right now it's on, looking for a connection, but the Bluetooth module is not on, as Adam will now turn on his Bluetooth module. As it turns on, now it's actually reading all of the data in terms of it's reading from him, the GATT server, as I'm the GATT client, and you can see it's doing multiple times, continuously running until I stopped, which is if I close the app. It is now disconnected, and that's because I closed the app.
We have a disconnect event coming from the server on the microcontroller, so the event was confirmed.
So this shows that our application was continuously reading from the server until it was terminated.